I did the part A and part B in my previous videos. If you want to see that, you can go ahead and look at it. In this video, I'm just gonna focus on the part C. The part C of the question is asking for the situation in B and disregarding the distortion caused by the Mosfet square law characteristic, what is the largest amplitude of a sine wave voltage signal that can be applied at the input while the transistor remains in saturation? What is the amplitude of the output voltage signal that results? What gain value does the combination of these amplitudes imply? By what percentage is this gain value different from the incremental gain value calculated above? Why is there a difference? Okay, now let's see all of them one by one. Okay, like if you watch my previous video, I calculated the VGS for the, there's a VGS for the Q I calculated, there's a VGS for the B point I calculated. All of them are previous questions. In the part B I did for the Q, that's the questions asking, and in the part A I did for the B and A, but here B and Q are the important things, so I'm just going to focus on that. So let's go ahead and write. So what the value I found for the VGS at Q is 1.5 voltage. That's from my previous part of the question. I did it. If you want to see how, you can watch my previous video. And VGS at point B also same thing. I calculated that one to be 1.605, and the difference between the gate source voltage at Q and B will give you the largest amplitude of the sine wave voltage applied to the input in order to keep the transistor in saturation. So we can mention that one here. Difference between gate to source voltages of Q and B will give the largest amplitude of sine wave voltage applied to the input. Sine wave voltage applied to the input in order to keep the transistor in saturation. In order to keep the transistor in saturation. Okay, so the VGS applied is going to be just the difference. You can see the difference, that is 0.105. So we can also mention the largest amplitude of sine wave voltage applied to the input VGS is 0.105 voltage, and that is one of the question for the situation in B and disregarding the distortion caused by the Mosfet square law characteristic. What is the largest amplitude of sine wave voltage signal that can be applied to the input while the transistor remains in saturation? That is this. VGS is 0.105. That's the largest amplitude. And the next part is asking what is the amplitude of the output voltage signal that receives. Okay, now we have to find out what's the output voltage that receives. And if you look at the transistor, the output voltage is basically the VDS. Okay, that's what we had to find out. Now let's try to find that one out. Okay, we can also mention that one here. Amplitude of output is obtained by multiplying the largest amplitude of input signal with voltage gain at point Q. So that is basically so to find out the VDS, what we do is we multiply this one by the gain, whatever the VGS we found out, and the gain I calculate it's in my previous video. So the gain is 12. I did it in my previous video. How do I get it? Here just I'm just gonna apply it VGS, and the gain I found out to be 12, and then the VGS we just calculated, that is 0.105. Apply that one over here. That gives us 1.26 voltage. Okay, that is our VDS, and that is our output voltage signal results. And the next part is asking what gain value does the combination of these two amplitudes imply. Okay, so the amplitude value that's going to imply VDS max, that's gonna be basically VDS from the previous one. Like if you watch my previous video, I got the VDS to be 2 voltage for the point B, point Q. Okay, so that one plus this one right here, that one comes out to be 2 voltage plus 1.26 voltage, which is equal to 3.26 voltage. Okay, and that is the answer for this part. And the next one is asking by what percentage is the gain value different from the incremental gain value calculated above. Why is there a difference? Okay, now in order to find out the percentage of the gain value, we need to find out the current first, and that will allow us to find out the gain, and we can see the difference. Okay, now in order to find out the current, I need to know the V overdrive voltage at point B. I already did it in part A of the question. If you want to see how did I go, you can watch that video. I got the value of V overdrive at point B to be this, VOV at point B to be 0.605 voltage. Why this useful is because we are going to use the current equation to find out the current. We need the V overdrive. The current equation in the train current equation is given by half Kn VOV square and kn values provided in the question, that is kn is basically kn prime w over L. So that whole thing represents kn, that is 1 milliampere per voltage square. I plug that one right here, 1 times 10 to the power minus 3, and then V overdrive is this 0.605 voltage square. And if we solve for this and find out the current, that is 0.183 milliampere. The reason we found out the current is because that will allow us to find out the gain. The gain equation is given by ID times RD divided by V overdrive divided by 2, and we just found out the current to be 0.183 milliampere, that is 10 to the power minus 3, and RD value is given in the question, that is 24 k ohm resistance. So I put that one right here, 24 times 10 to the power 3, and then V overdrive we already know that is 0.605, and that one divided by 2, and that will allow us to find out the gain, and that comes out to be 14.52. Now we have the gain. Now we can go ahead and find out the voltage gain difference, and we know the gain at Q, that is I did in my previous video, that is 12, and we found out the gain at B, that is 14.52. so we can see the percentage difference. To find out the gain percentage difference, we have to use an equation. So percentage voltage gain difference between Q and B point is we have to just put this equation AVQ minus AVB divided by AVB multiplied by 100, and that's going to give the percentage difference. And let's put that in an equation, AVQ minus AVB times the 100, and which is equal to, we just found out the gain difference at Q, at B, that is, wait a minute, let me double check the graph. B is right here, Q is right here. We just solve for the V overdrive voltage is B, and this one is B. This 14.52 belongs to the B. So this equation should be rearranged because the biggest value should be here, then only I can take the percentage. So this one should be Q, and then Q, B, and then divided by B. That makes sense. Yeah, it was exactly like that. I was the one confused. Okay, wait a minute, let me double check. This is AVB, that's 14.52. So mistake. So this is B, and then this is Q, and then Q. Okay, B, Q, and then Q. So B is B just for B we just found out to be 14.52 minus 12, that's Q, divided by 12 times 100, and that comes out to be 21%. Okay, that is the percentage voltage gain difference. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my